In our last explainer, we really dug into cross-site scripting, which you might think of as the classic way to attack users. But in this chapter, we're going to explore a whole other world of techniques that are often way more subtle. These are the kinds of attacks that can slip right past basic XSS protections, and that makes them absolutely essential to understand if you're serious about web security.
Now, this sounds like something out of a movie, right? But believe it or not, this actually happened. Back in 2004, eBay had a vulnerability that did exactly this. An attacker could set up a malicious auction, and if you were logged in and just looked at the item, poof, you just placed a bid. It's a perfect real-world example of the kind of powerful and, frankly, sneaky attacks we're going to break down today.
All right, here's our game plan. First, we'll look at how attackers can literally forge requests from your browser. Then we'll get into the visual trickery of deception and UI redress attacks. After that, we'll see how data can be stolen across different websites. Next, we'll dive into the attacks that go straight for your session cookies. And finally, we'll round things out with some other key client-side attacks.
So first up, forging user requests. This whole section is about turning your own web browser against you. The crazy part is, attackers don't need to find a bug in the browser itself. Instead, they exploit its normal, everyday functions, tricking it into making requests you never, ever intended, all while using your login session to do their dirty work. Let's start with something called On-Site Request Forgery, or OSRF. Now, what's so interesting about this one is that it can work even if a website has done a good job blocking XSS. They've properly encoded all the dangerous characters so you can't inject a script. But OSRF doesn't need to inject anything new. It just cleverly manipulates parts of a URL that are already allowed on the page.
Okay, let's look at a real example to see how this works. Imagine a forum where you can set a URL for your profile picture. The site won't let you inject a script, but it will let you change the path to the image. So an attacker sets this payload as their image source. Now, when an admin comes along and views the attacker's profile, their browser automatically tries to load the image. But it's not an image, is it? It's a command to create a new admin user. And check out that little hash symbol at the end. That's a neat trick to make the browser ignore whatever came after it, like the original .give file extension. Building on that is the much more common and powerful version, Cross-Site Request Forgery, or CSRF. I love the nickname session writing because it perfectly captures what's happening. The attacker doesn't steal your login credentials. They just get your browser to send the request for them, essentially riding along on your active logged-in session.
So how does this play out? Well, picture this. Step 1, you log in to your bank. Step 2, you get an email with a link and click on it, taking you to some other website an attacker controls. Step 3, instantly and invisibly, that attacker's site sends a request back to your bank. And here, this is the absolute key. Step 4, your browser, just trying to be helpful, automatically attaches your banking session cookie to that request. So step 5, the bank gets the request, sees a valid cookie, and thinks it's you, processing whatever malicious action the attacker cooked up.
So, how do they actually launch that hidden request? One of the simplest methods is just a standard HTML form, hidden on the attacker's page. The form is pointed at the vulnerable function on the bank's website. All the details, like what action to perform, are pre-filled in hidden fields. Then, a tiny bit of JavaScript automatically clicks Submit the very instant you load the page. You see nothing, but in the background, your browser just did the attacker's. Naturally, as developers got wise to CSRF, they built defenses, like secret tokens on every page. But security is a cat-and-mouse game, and attackers evolved. This next type of attack, called UI redress, or more famously clickjacking, gets around those defenses by tricking your eyes and hijacking your literal mouse clicks.
Before I show you how it works, just think about this for a second. When you click a button on a website, how do you really know what you're interacting with? Clickjacking is all about exploiting that little gap between what you think you see and what's actually there. And this image shows the trick perfectly. The attacker makes a tempting page with something like a click-to-win button. But here's the magic trick. Hidden underneath, they've loaded your actual banking website in a totally transparent window called an iframe. They've lined up the invisible Confirm Transfer button from your bank exactly on top of the click-to-win button you can see. So when you go for the prize, your click goes straight through the fake button and lands on the real one.
Now, the reason this is so devastatingly effective is that it totally bypasses those anti-CSRF tokens we just talked about. From the bank's point of view, everything looks legit. The click came from the real page, it was just invisible, so the browser sends the request with the correct, valid anti-CSRF token. The server has absolutely no idea it's being displayed in a malicious, invisible frame.
The first attempts to fight this were called frame-busting scripts.
They were bits of JavaScript that tried to detect if the page was inside a frame and then bust out. But it turned out these were pretty easy for attackers to defeat. The modern and way more effective solution is a simple instruction from the server called the X-frame options header. It's not a suggestion, it's a direct command to the browser telling it whether or not the page is allowed to be put in a frame at all. Problem solved. Okay, now we're going to shift gears and look at attacks that try to break one of the core security rules of the entire web, the same origin policy. Now, this policy is basically the digital wall that's supposed to stop a sketchy website like evil.com from reading the data on your OpenTab for yourbank.com. But that wall has some cracks. So how do attackers peek over that wall to steal things like, say, a secret CSRF token? We're going to look at three main techniques: HTML injection, a really clever one called CSS injection, and JavaScript hijacking. CSS injection is just brilliant. It's so clever. Imagine an attacker can inject just a tiny bit of text into a page. They inject what looks like the beginning of a CSS style. Then, on their own malicious site, they tell the browser to load the victim's page as if it were a style sheet. Some browsers will get confused and start reading the page, see the font family property, and just keep reading all the text that comes after it, including your secret data, thinking it's the name of a font. The attacker can then use JavaScript to ask, "Hey, what's that font name?" And poof, they've just stolen the data. JavaScript hijacking really took off with the rise of modern dynamic web apps. The problem is, when an application sends back sensitive data that also happens to be perfectly valid, runnable JavaScript, like a JSON array, an attacker can then use a script tag on their own site that points to the app's data URL. Now, the same origin policy doesn't block loading scripts, so the browser fetches the data, thinks it's a script, and runs it. By cleverly redefining some basic JavaScript functions, the attacker's code can intercept that sensitive data as it's being processed and ship it off to their own server. So far, we've seen attacks that right on top of a user's session. But now, let's talk about attacks that go straight for the jugular, the session token itself. That's the little piece of data that proves who you are after you log in. Session fixation is really cool because it completely flips the script on normal session hijacking. Instead of trying to steal your session token, the attacker gets a brand new anonymous token from the website first. Then, they trick you into using that token. When you log in, the website upgrades that very same token to be authenticated for your account. And since the attacker already has it, they're in. Let's walk through that playbook. Step 1. The attacker gets an anonymous session ID from the logging page. Step 2. They craft a special link with that ID in it and send it to the victim. Step 3. The victim clicks the link and logs in like normal. Now, here's the fatal flaw. The application doesn't give them a fresh session token. It just promotes the one the attacker gave them. So, step 4, the attacker, who's had that token all along, can now use it to waltz right into the victim's account. And the fix is so simple. Just always give the user a new session token after they log in.
To wrap things up, let's touch on a couple of other important attacks. These get down into the nitty-gritty, targeting the invisible messages that your browser and the web server are constantly sending back and forth.
HTTP header injection happens when a website carelessly includes something a user typed directly into a response header. If an attacker can sneak in the code for a new line character, they can essentially hit enter inside that header and start writing their own headers. This can let them do things like set malicious cookies on your browser, or even worse, perform something called HTTP response splitting, where they can actually chop one server response into two, which can be used to trick other users or systems. So, let's boil all this down. What are the big takeaways here? First, the very things that make browsers helpful, like automatically sending cookies, are the exact same things that attackers love to exploit. Second, we've seen that user actions can be faked with CSRF or stolen with clickjacking. Third, that big wall, the same origin policy, isn't as solid as we'd like to think. Fourth, session management is everything. You have to issue a new token after login. And finally, there's no silver bullet. Real security is all about having layers of defense. And this brings us to one last thing to think about. As the web gets more and more complex, with all these amazing new technologies like HTML5, we're building incredible new things. But every new feature also creates a new attack surface. So it makes you wonder, are we actually making the web more secure, or are we just in a constant arms race, building bigger and more complex playgrounds for the next generation of attacks?